Hello everyone, we are Alpha Medical System and our product is Mednet. Mednet is a product that is able to help both patients and doctors within the medical field. The main problem our product deals with is the inefficiency and delay which occurs when trying to communicate between doctor or patient. This product is mainly for the patients who need some help to find a doctor or want to communicate with the doctor before they meet, and for the doctors who want to choose which patient they want to deal with. But almost anyone is able to use our product. For more details, patients can submit tickets notifying multiple doctors of their situation under an unknown identity. From the doctor's side, they will be able to choose any of the tickets to assign themselves as the doctor for a chosen patient. After a doctor chooses a patient's ticket, the doctor will gain access to the chosen patient's records. From the patient's side, after a doctor has chosen his or her ticket, the patient will be notified who he or her doctor is and gain access to the doctor's contact information. Our product takes a more modern approach than the conventional method of cabinet and file storing. At the same time, our product is helpful for the patients who don't have enough time to go into a hospital and schedule an appointment just to wait for a doctor to become available. So, what are the requirements for our product?
Okay, so for our product, there are two kinds of actors, the doctor and the patient, and they both interact with the database through multiple use cases. Most of the use cases require connection to the internet because our product is mainly used to transfer information. To come up with these use cases, we thought of what functionalities the user would want when using our system. We made a login and register use case because we wanted the user to be unique and have some sort of security to identify one user from the next. The other use cases revolve around a ticket object, which is an object that a patient creates when he or she requires medical attention, and also the ability to edit the information of the actors. Our system contains 4 different objects: a user, a patient, a doctor, and a ticket. The patient and doctor objects are generalizations of the user object, and the ticket object represents the connection between both the doctor and patient object. The way that the classes relate are that the doctor and patient will inherit attributes and methods from the user class, which include the ability to register, the ability to log in if the user already has an account, the ability to obtain a forgotten password, along with other interactions. At the same time, patients and doctors will have different use cases. Patients will be able to create multiple tickets, and once a doctor has chosen a ticket to associate with, the patient can view doctor's information to see which doctor has chosen their ticket. Doctors, on the other hand, have the ability to choose a ticket, and once they have chosen a ticket, they can view all of their chosen tickets in a list. So a ticket object can only be linked to one patient and one doctor at a time, but a patient and doctor object can have multiple tickets associated with them. The ticket object has attributes of a ticket ID, patient key, doctor key, date of creation, and description. The patient key is used to identify who created the ticket, and the doctor key is used to identify which doctor will be assigned to that patient. So the next question is, how did we design our system?
We designed our system where the objects have either a string attribute or an integer attribute. The string attributes would be used to transfer information between the objects, while the integer attribute will define how the objects will be connected. Most of the methods included in each object are void because they either initialize another instance of an object or they perform an action that interacts with the database. Since our system involves transferring large amounts of information between the users, we decided to have a shared repository type architecture for our system. Now, a shared repository type architecture is where all the information of a system is stored in a central repository that each component of the system is able to access. This seems reasonable since the main purpose of our system is mainly to transfer large amounts of information between users. Since our system has 2 actors, a doctor and a patient, this means that either one is able to log into the system at any time. These actors only exist from the time they log in to the time they log out. However, if the login information is incorrect, the user, which could be a doctor or a patient, will be unable to access the system. The ticket is the main point of information transfer in our system. If a ticket has not been created, no information should be transferred between the system components, other than the information required to register an account. However, when a patient has created a ticket with a description of the patient's medical needs, the ticket will be stored in a database. From there, the patient will be able to edit their ticket anytime they want, or a doctor will choose to accept the ticket from the database. The lifetime of the ticket will only exist from when the patient creates it to when either the patient or the doctor resolves the ticket. Basically, the patient's medical needs and the patient's personal records will be transferred to the doctor through the ticket.
So we've talked about the different users in our program and the attributes that they will have. And we've also talked about the architecture of our program, so now let's talk about how we're going to implement these ideas. We knew that we would need a database to store all the user information, and that all of our methods would require interacting with the database, and it would also require an application that the user could interact with. So we decided to code the application in Java and use MySQL for the database. The first thing that we did was take a look at all of our cases and decided that the create ticket use case and the choose ticket use case were the most vital to our system. Since the ticket is the source of the information transfer, we decided that the create ticket case was one of the most important cases. To start, we first looked at the use case for create ticket and created a sequence diagram based off of it. From the sequence diagram, you can see that the patient has to log in first in order to create a ticket. From there, they have two alternatives, which is able to create a new ticket and send it to the database so the doctor can view it, or else if the information they submitted is invalid, an error message should be returned. For the choose ticket use case, you can see that it can only be accessed by a doctor. They first have to log in before being confronted with two alternatives. One, the database either has tickets for them to choose from, or two, there are no tickets in the database. If there are open tickets in the database, then the doctor will be able to pick and choose which patients they would like to help and select that ticket. In order to implement the rest of the system, we used Eclipse and the Window Builder plugin, which allows us to drag and drop all the buttons, text fields, and labels into frame and position them where we wanted them to. In order to store the information that the user enters into the database, when the user first registers for an account, we take everything as a string and send it to the database, where the user is identified by their username. When a user sends a ticket to the database, it is identified by ticket ID, which is attached to the ticket, and the rest of the information that the user enters is attached as a string and sent to the database along with the ticket ID.
In the beginning of implementation, we were able to test two use cases, register and login, because those are the first features shown to the user when starting up our application. These use cases allowed us to use specific cases for proper testing of the connection to the database and to make sure that the output of each button click would result in the correct action performed. Username, password, and additional user info are stored in our Mednet database. Much of the testing for these test cases was done by using preset values run by a separate main method created specifically for testing, which pulled info already in the database or introduced new info. This allowed us to test for proper functionality of the system. For the login and register, username and password must be in the database fields. These respective on-click buttons should navigate to their intended corresponding pages. Running the login page would show whether or not the database driver was working correctly and/or properly coded. The register page also showed if a database connection was actually established. Various branches for the preset values considered to test if the user input was allowed in their specific input fields before being entered into the database. For both the login and register test cases, correct format in the input fields along with each button click was made sure to lead to the new correct frame, which is what all users should expect to see if the program is running as intended. One of the validation techniques we used was to have a user to try register as a patient and as a doctor. For example, one of the bugs found was the register button, which would not connect to the database after all the empty fields criteria had been met. We then checked the source code for that specific method to understand the reason of failure. These sample test cases helped us answer a couple of questions necessary for any program. Is our system functioning correctly, and is it working properly by giving the user the correct information back to them? Further testing can be carried out to verify Mednet's dependability to further answer the more important questions to meet the original requirements. Does this meet the client's needs, and does it meet